Hi everyone, so in this tutorial I'm going to show you how you can add coordinates and grid cells properly in your QGIS map. Most of the times many of my friends have told me they are facing some problems while adding coordinates of specific size and all. For example, sometimes if they try to add grids or coordinates, sometimes nothing appears, and sometimes there will be a thick black line at one corner of this map canvas. So there are a few issues. So in this tutorial I'll be addressing those issues, and I will tell you how you can add these coordinates and grid cells properly. So let's begin. First of all, I'm going to start a new empty project in my QGIS, and you need to add a shapefile or a polygon representing your study area. In this example, I'm going to use a shapefile which is already in my system. So you can get this shapefile or the QGIS file from the download link I have provided in the description, so that you can repeat or do this whatever I'm doing in this tutorial on your own. So I'm going to add this particular QGIS file into my QGIS just by dragging and dropping. Now you can see the polygon has appeared, which was actually a QGIS file, and I'm going to change the color a little bit by going to the layer, right clicking, and going to properties. And if I go to simple fill, I can change the fill color. Okay, and I'm increasing the stroke width a little bit and reducing the transparency. Anyways, this is not important. What important is adding coordinates and grid cells. So okay, so I'm scrolling in and keeping it right at the center of the canvas. And next, let's go and create a study area map. So I have already uploaded an elaborated tutorial on how to create a study area map. So if you want to know further details about creating study area map, you can check out that particular tutorial. The link towards that video I have provided in the description below. Just check it out. And now let's start with creating a map. So I'm going to click here, new print layout, and OK, done. And I'm going to draw a map here by clicking this option, add map. And you can drag and click and drag to copy this particular polygon into your map canvas. That's it. So now comes the important part. We are going to add grid cells and we will be adding coordinates. So for that, I'm going to right click on this layer. I'm going to item properties, and if I go down, okay, so first of all, you need to specify a CRS for your map. So if I click on this drop down menu right here, you can see there are multiple CRS. So the project CRS EPSG 4326 WGS84 and the EPSG 3857 WGS84, or the pseudo Mercator, are two of the widely used CRS coordinate reference systems in QGIS. So you need to have an understanding of these two CRSs before proceeding with creating, adding grid cells and then coordinates. So let's have a look at what are these coordinate reference systems are. So this is my presentation. So we all know about coordinates, right? So coordinates are basically of two types: geographic coordinates and Cartesian coordinates. Geographic coordinates are nothing but degrees. So you are already familiar with longitude and latitude, and consider if you have a point in this globe here. So how do you define this point? It can be defined using longitude and latitude. This point will be having a longitude value and a latitude value. So in this geographic coordinates, we actually consider the ellipsoidal model of the Earth, which means we are considering Earth as a globe. But if you look at here in this Cartesian coordinate system, here the coordinates will be in meters. Here it was in degrees, but here it will be in meters. and instead of longitude and latitude we'll use X and Y. For example, if we have a point here, right here, and if I ask you to define it, and you can define it by telling its corresponding X coordinate and Y coordinates, which is going to be 3 and 2. So the coordinates for this point will be 3 and 2, but here it was a latitude value and a longitude value. So that's the main difference between geographic coordinates and Cartesian coordinates. So we call it an ellipsoidal model, but this one is a Mercator projection. Actually, we are projecting this ellipsoidal surface of Earth onto a two-dimensional surface, planar surface, and this is a projected map, and this is the kind of ellipsoidal model of the Earth, representing Earth as it was or as it is. Okay, now you are familiar with two different types of coordinates, and now let's have a look at the coordinate reference systems widely used in QGIS, the EPSG 4326 WGS 84 and the EPSG 3857 WGS 84. So it means that the EPSG 4326 CRS coordinate reference system is based on geographic coordinates. So the unit of measurement will be degrees in the map, and you will use latitude and longitude to define the geographical features and points within this particular CRS. But if you look at the EPSG 3857 WGS 84, it is based on the Cartesian coordinates. So the unit of measurement will be in meters, and you define a point or a feature using X and Y values. So if we go back, we saw the same thing here, right? CRS, under this drop down menu we saw EPSG 3857 and EPSG 4326, and this is another CRS, and this one is specifically for my study area, Kerala. So there are plenty of CRSs for different regions in the world, but the popularly used one or generally used ones are EPSG 4326 and EPSG 3857. These can be used for any locations on our planet, so that's why we are focusing on these two only now. And the major differences between these two CRSs are: the EPSG 4326 is widely used for global mapping, navigation and GPS, and it is the default CRS for QGIS. So when you open QGIS, you would have noticed that the default CRS will be already set into EPSG 4326, whereas in this case EPSG 3857, it is the standard for web mapping application like Google Map, Cartomap, Bing Map, OpenStreetMap, S3 and all. So most of the web maps uses this particular coordinate reference system for their map, and we are already familiar with Bing Map, Google Map, OpenStreetMap and all, so I'm not elaborating further. But the problem is that the EPSG 4326 is suitable for applications requiring accurate geographic coordinates. So the measurement you make using this particular CRS will be accurate, considering or in contrast to EPSG 3857, in which the distortion will be increasing at higher latitudes, making it less suitable for accurate area or distance measurement. For an example, in this particular map, the world map, you might have seen this in your office room, classroom and also in this map the size of the Africa will be same as that of the country of Greenland. Greenland looks like a large country in this particular two-dimensional map, and it is due to distortion. Actually, Greenland is very small, smaller than Africa. And the reason why it appears larger is because it's situated near the polar region. So the countries at the polar region will appear larger than they actually are due to the distortion happening in this particular coordinate reference system, EPSG 3857. Anyways, in this case, EPSG 4326, the map unit is degrees. We already discussed in the previous slide. Whereas in the EPSG 3857, the map unit will be in meters. So the important point is that when you are creating grids, and if you are using EPSG 4326, you should be specifying the grid size in degrees. Whereas if you are using EPSG 387, you should be specifying the grid cell size in meters. So that is the major difference. The first one uses map unit degrees as its map unit, whereas the second one uses meters as its map unit. Now let's go back to our tutorial. So here it goes. First we will choose the EPSG 3857 pseudo Mercator projection. So in this one we will be using meters for specifying the grid cell size and for adding coordinates. So done, and I'm scrolling down now and you can see grids here, right? Click here. I'm going to add a new grid. I'm selecting it and I'm modifying it, and again you can see CRS here. So I'm going to choose the same CRS again, EPSG 3857. And now you can see X and Y, right? So in this case, this is based on this particular CRS is based on the Cartesian coordinate system. This one. So you should be providing the X and Y values in meters. So that is what I'm going to do now. So if you give 1 and 1, this is what you are going to get. Many people have got similar error or issue in QGIS when they are making map, and this is due to the fact that we are actually putting values in meters here. So if you put 1 here and 1, it's going to be problematic. So instead I'm giving 10,000 and 10,000. So you can see the grid cells, right? And if you want to measure the distance, so this will be 10 kilometer and 10 kilometer, or 10,000 meter and 10,000 meter. So you can use this add scale option to measure the approximate distance between these 2 points. This distance between this point and this point is supposed to be 10 kilometer. Let's check it by adding this add scale bar option. Let's keep it here. Okay, see, the distance between this point and this point as we have provided is approximately 10 kilometer, but it's not exactly 10. This is due to the distortion occurs in this particular map projection. See, we used EPSG 3857, right? So as you go towards the as you go to higher latitude, the distortion will become higher and higher. But still in this particular region in Kerala also some sort of distortions will be there, and that is the reason why the distance between this point and this point is not exactly 10 kilometer. And now our next target or next objective is to add coordinates. I'm keeping this scale bar here, and I'm right clicking on the item properties, and I'm scrolling down to choose grids, and this is the grids we have already prepared, and click modify grid. And as you know, the CRS has been specified, and the interval, the X and Y values in meters. So the size of these grid cells are given in meters. 10,000 meters by 10,000 meter. I'm going to change the line style. I want to reduce the opacity. Okay, done. And if I go further down, you will find an option called frame. So under frame style, no frame, I'm going to change it into interior ticks. So you can see the ticks being shown. And if I further scroll down, you will find an option called draw coordinates. So if you click here, the coordinates will be added on all those ticks here, you can see, right? And the format is in decimal, and you won't find any other options here. So you can add coordinates only in decimal format, decimal or decimal with suffix. And this is the issue with EPSG 3857. So if you have chosen this particular CRS, then you won't be able to add coordinates in degree, minute, second format, DMS format. You are left with only these two options, decimal and decimal with suffix, and you can add those inside the frame by clicking here, inside, 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 and inside. So this is one way of doing it. If you are using EPSG 3857, then this is how you are going to add coordinates and grid cells. You can control the grid cell size by changing this value, so that the position of coordinates will also change. Now it's 15,000, which means 15 kilometer, 15 by 15 kilometer. So this way you can play with it and adjust the values and get these coordinates or these lines arranged properly. Now let's create coordinates using the other CRS, which is EPSG 4326. So I'm going to right click and go into item properties, and here I'm going to change the CRS into EPSG 4326, which is the default CRS for QGIS, and it will be more accurate than the EPSG 3857. I'm scrolling down and you will find an option called grids. And if you click on the grid we just created, and if you click modify, you will find an option to change the CRS here, right? So I'm clicking here and I'm changing it into EPSG 4326, the default CRS. So now all those grid cells have disappeared, because here the X and Y values are going to be nothing but the longitude and latitude, or the latitude or the longitude. So what we have provided here, that the latitude or the longitude is going to be 15,000 degrees, and Y or the latitude or longitude is going to be, okay, let X be the latitude and Y be the longitude. So we specified that the latitude is going to be 15,000 degrees and the longitude is going to be 15,000 degrees. So how many kilometers are 1 degree? Let's have a look at it. 1 degree in EPSG 4326 to kilometer. So 1 degree is equal to 111 kilometers. So these many degrees will be equal to a large number. So that is the reason why you are not able to find any grid cells here. So the distance between this point and this point won't be 15,000 degrees. It will be very small. So let us put 1, which means the size of the grid cells will be 111 kilometers, 1 degree. So we have put 1 degree latitude and 1 degree longitude, and this is what we got. Still it's too large, the grid cell size, right? So I'm going to further reduce it. Let's put 0.01 and 0.01. Okay, sorry, 0.1 and 0.1. Okay, which means 0.1 is 1/10th of a degree, which will be 111 by 10 kilometer, which will be 11 point something, I think. So that's it. And the good thing is that in this, if you're choosing EPSG 4326, you will get a lot of different coordinates formats for your coordinates: decimal with some suffix, degree minute with suffix, so on and so forth. So I'm going to choose degree minute, and everything is already inside the frame. And if you want to measure the distance, you can again use this scale option. Click here and measure. So 111 by 10, 11.1 kilometer. So 0.1 degree is equal to 11.1 kilometer. That's what we got here. We provided 0.1 latitude and 0.1 longitude, right? So it is going to be 11.1 kilometer distance from this point to this point approximately. And if you use EPSG 4326, you can add a lot of different formats for your coordinates, and that's the main use of it, using this particular CRS, and it will be more accurate than the PSG 3857. So you should pay attention to the CRS. Then you have to specify the X and Y values. Then only you will be able to create grid cells and then the corresponding coordinates. So that's how it's done generally, and make sure that you are paying attention to the coordinate reference system. So the rest of the stuff will be will be easy if you have a well understanding of the CRSs. So that's it. Thank you everyone. We'll meet in my next video.